Good morning, everyone. My name is Kathy. I am here to give my second presentation on microservices. Here I will be discussing about the design pattern, what we use in microservices, about the tool, what are used in microservices, and about its architecture. So let's understand this term with an example. Suppose I am an organization and I have some requirements like I want to create an employee and customer management system. Like I want some people who can manage our application and provide services to the customer. So basically what I want to create an application and want to manage it. So what is our application? That is employee customer management system. So as an organizer, I want some requirements which should have some add features like I want to add some employee details or add some customer details or any related details of employees and customer. Then then these are the requirements. In second, we want some delete features, like I should have some delete features so that I can remove customer and also the employee details. Then in third, I also want some update features so that I can update or modify any employee account. So these are the requirements which I want to put in employee and customer management system. Now we will be creating some of the modules in employee customer management system. Firstly, we will create a separate module for employee. Then we will create a separate module for customer as well, where we will be managing our customer. Then we have a separate module for courses where we will be providing courses to the student and also student can enroll over here. Then we have address module where all the information about the employee and the customer is stored here, and about the shipping address also is going to be stored here. So now let's think we have created some of the endpoints related to the specific modules. Through endpoints, we get information about that specific modules. One of the endpoints we have discussed how to create it and how to check it through Postman. In our previous video, we have discussed how to create uh, an API through Eclipse, and through Postman we tested it. Only we have to think we have created all these modules and we have developed all these uh, endpoints to the specific controller in Java class. And what we did, we just wrap up all these modules under a single zip file and deployed over the server. Basically, we have our database here which is going to be connected with all those modules which have a separate table for this employee these employee modules, a separate table for the customer module, for separate table for the course module, and a separate table for the address module over our database. So basically this type of architecture, wrapping up of data into a single zip file and deploying over the server, this type of architecture is only called the monolithic architecture. So firstly we should know what is monolithic. So in monolithic architecture, that same thing we are performing, which I have shown here. We are wrapping all the component module under a single zip file and we are deploying it on the server. This is called a traditional approach. But for now, some of the requirements are changing related to the monolithic architecture. Some of the requirements we will be discussing further. So this is the diagrammatic form of monolithic architecture. In this, we have user interface. The second layer is business logic. Here, all of the four modules, whatever we discussed here, employee modules, customer, course, address module, all of the four modules is present in the business logic. In the third phase, we have DAO layer, which is basically connected to the database. So this is only the monolithic architecture which is called the traditional monolithic architecture. So next come dealing with the problem with monolithic architecture. So let's see what are the problems with monolithic architecture and why the developers are moving towards the microservices. So let's understand with an example. Our first challenge, let's see what is our first challenge. Uh, Imagine we have a requirement. So right now we have three different teams. One team is working on employee module, other is working on course module, and the other team is working on the customer module. Now they all do the continuous development and push their changes to the Git, and the Jenkins creates a build over it and push it to the server. And so our client needs some changes in customer module, sorry, course module. So as a developer of course module, they do some changes in the code base and push it to the Git. Let's say the course code goes to the Jenkins and the Jenkins picks up the code and creates a build and deploy it over the server. And once the code is deployed over the server and it runs over the server, the developer tested the changes which has been made and they found that the code is working properly. No scenario occurs. The customer cannot log into their account after the deployment of the project. So, as per the developer of the course module, the new feature that has been implemented and deployed over the server, everything was fixed and working good. So, according to the tester team, everything is working good in the new feature, but something went wrong with the customer module. So, as per the developer things, we made some changes in the course module and how there is something wrong in the customer module. So, a question comes how these two things are related to each other. So, I have total, I have told. So, so this is because of the monolithic architecture. We have discussed previously our entire application is getting zipped and deploying together on the server. So the problems occurs. So here are the two problems over here coming. Our first problem is a. So first problem we will discuss here is any changes on the code. Let me to test our entire application. Our entire application. So let me explain the sentence what it is telling. So in the previous slide we saw the developer did some changes in the course module. For that the tester needed to run all the entire test cases which has been written for all of the specific modules and trying finding it out whether the issue is. So any changes made in the course code base, maybe in the course module or in the customer module or in the address module, the tester has to test the entire application because any changes in one module can impact the other module. So this is the first scenario which occurs in monolithic architecture. Now second we will be discussing about the second problem. Developer may not have knowledge of all the modules, making it harder for fix the issue. So imagine a scenario right now. A developer did some changes in the course module and something broken in the customer module. So the developer who is working in one module, he might not have idea about all the modules and he cannot fix the issue in other module. So this is the problem with the monolithic architecture. A single developer cannot have an idea about all of the modules which are created. So it is harder to fix and it is harder to start with this application. So let's discuss the third challenges. Now let's think a client have given some offer. That is every new user and customer will get 20% off in their courses. Okay. Let's say the courses are available in 5,000. Now, as I say 20% off for new user, what is going to happen? The user will come start signing up and start creating new user account on the website. So there may be a probability a huge number of students get enrolled over the account. So any application can't takes a lot and lot of load. So our server have some capacity which can handle. So let's say our server can handle only hundreds of requests, but there are 1,000, 2,000 people requests are coming in the server. So our server is going to perform slow and the people will not be able to browse the application properly because there are tons of requests coming to the particular server. Basically, our server cannot handle so much of tolerance and it will it will start working slow. So what we can do as a solution to solve this issue? So let's understand both of the architecture with some examples and differences. In monolithic architecture, as monolithic architectures are simple for small applications but become difficult to scale and maintain as the application grows. But in microservices, but in services it uh, offers better scalability, flexibility, but comes with added complexity in managing the distributed services and communication. Okay, let's see the structure of both of them. Monolithic architecture is a single unified application, and microservices is a composed of independent small services. It's independently provides services to the customer as per the requirement. Let's talk about the deployments of this architecture. In monolithic architecture, entire application is deployed in a single unit. In microservices architecture, service can be deployed independently. Now, next comes the development speed. Monolithic architecture is slower as the changes to one part of as the changes in one part affects the other module also. As we have discussed in the previous slide, we have seen some of the scenarios. But in microservices is faster with terms working on the different services independently. Now let's come to the fault tolerance. In monolithic architecture, a failure in one part can bring down the whole application. This point also we have uh, discussed before. In microservices, failure are isolated to the affect the services and minimizing the impact. Now let's talk about the complexity. Monolithic architecture is easier to develop initially but harder to manage as it grows. But in microservices, it is more complex to set up and manage due to the services are and it is harder to communicate. So as a conclusion, monolithic architectures are similar to develop and deploy initially, but can become rigid and harder to scale. But in microservices offers great flexibility, scalability, and the fault tolerance. Some of the key feature in microservices. First one is independent service. Each microservices is a self-contained unit that focus on a specific business function and can be deployed, scaled independently. Second one is loosely coupled. Services in microservices are loosely coupled, meaning changing in one services cannot affect the other. Now the third is scalability. Individual service can be scaled independently based on demand, improving service efficiency. The fourth is decentralized database management system. In microservices, each service typically manages its own database or data source, reducing the data dependencies. Now next is the fault isolation. Failure in one services does not impact the entire system, improving the system resilience and the fault tolerance. Now, next, talking about the technology diversity. Each service used different programming language, databases, or different framework based on their specific needs. Now, next is continuous deployment in microservices. Services can be continuously integrated and deployed without affecting the rest of the application. Now, the next is improved team structure in microservices. Team can work independently on different services without the interference of each other services. Now, the next is service communication. Service communication with each other. The services communicate with each other through HTTP, through APIs, or messaging system. So these are some of the key points we have discussed in microservices. Now let's see the working of microservices. Microservices architecture operates by breaking down an application into small independent providing functionality to the services. Let's see how it works. Here the application is split into the smaller autonomous services, each handling a specific business function, for example, order processing, payment, user management, etc. Each microservices is self-contained and independent services. Now, the next is service communication. Microservices communicate with each other using lightweight protocol like HTTP REST or messaging queries. Each services exposes API for other service or the client to interact with it. It it provides independent deployment. Microservices are independently deployable. Team can update, test, release new version of services without affecting the other part of the system. Continuous integration, continuous deployment automates the deployment process. Then it have decentralized database management system. Each microservices typically have its own database or data store, meaning each services manages its own database independently. This eliminates the need for a centralized database, improving the scalability and the fault tolerance. Like it have every services has its own database. Like in monolithic architecture, we have seen we have a single database. All the modules were connected to a single database, but in microservices, what we have every services is having their own database. So the next point comes in services interact with their own database and may use APIs to share their information. These services communicate with each other through APIs. Now, the next comes in microservices load balancing and scaling. Load balancing is used to distribute incoming traffic across multiple instances of same services to handle high volume of the request. Like we have seen, uh, we have created different servers for handling the request. When we have created an offer for the students, so many students were enrolling at a time. So there, that was a condition where we need to handle our servers because it will tend to fail. It cannot tolerate that much of request at a time. It has a specific capacity to handle the request. So what we do, we divide the servers into multiple servers and connect to a single database. So this is the next time services can be scaled independently, adding more instances of a service that is under heavy load without scaling the entire system. Means all the loads are not coming to a single server, we are dividing into the multiple servers. Now the next point comes in microservices. It has fault tolerance. Microservices are designed for resilience. If one service fails, the rest of the systems can continue functioning. Just because they are not connected with each other, they have their own database.